Myself Ankita. Today we will be discussing about some important questions on basic electronics. So we will start from the first question. Our first question is electron hole pair are produced by thermal energy. When heat is applied, then electron hole pair are produced. So here thermal energy will be the correct answer. Moving towards the next question, recombination is when an electron recombination is always occurred when an electron falls into a hole. In recombination there is an attraction force between an electron and a hole. So here option A will be the correct answer. In question number 3, each atom in a silicon crystal has in silicon crystal there are 8 valence electrons, 4 of its own and 4 its shared. In silicon it forms covalent bond which shares its 4 and as 4 as its own. So here option C will be the correct answer. In question number 4, the current in a semiconductor is produced by in semiconductor current is produced by electrons and holes. Electron in semiconductor there is the repulsion and there is an attraction force between electrons and holes. So it is the current is produced by electrons and holes. Moving towards the next question. In question number 5, the process of adding an impurity to an intrinsic semiconductor is called. In intrinsic semiconductor, we add impurity to increase its conductivity. So this process is called doping. This is called doping, when we add some impurity to intrinsic semiconductor to increase its conductivity. The semiconductor becomes well better. So doping is used. In 6th number question, a trivalent impurity is added to silicon to create p-type semiconductor. If this question will be a pentavalent impurity is added to silicon to create an n-type, but here trivalent impurity, there will be the answer p-type. And if pentavalent, then it will be n-type, but here is trivalent, so p-type will be the answer. Moving towards the 7th question, the purpose of pentavalent impurity has the purpose to increase the number of free electrons. If there will be the question, the purpose of trivalent impurity, then there will be the answer. The purpose of trivalent impurity is to increase the number of holes. But in pentavalent impurity, to increase the number of free electrons. So C will be the correct answer. Moving towards the 8th question, for a silicon diode, the value of the forward bias voltage typically. In silicon diode, the forward voltage should be 0.7 volt or greater than 0.7 volt. If there will be germanium, then there will be 0.3 volt. But here is silicon, so here it will be 0.7 volt. So must be greater than 0.7 volt. Moving towards the 9th question, when forward biased a diode when any semiconductor is in forward bias, then a diode conducts current. If it is in reverse bias, then it behaves like an open circuit. It will not conduct current. But here is question is asking in forward biased. In forward biased, a diode conducts current. It will conduct current. So here B will be the correct answer. It will act as a closed circuit. Now in 10th question, when a voltmeter is placed across a forward biased voltage, it will read a voltage approximately. In forward biased voltage, voltmeter reads approximately the diode barrier potential. We know the barrier potential is also known as knee voltage, etc. So when a voltmeter is placed across a forward bias voltage, it will read a voltage approximately equal to the diode barrier potential. Now in 11th question, the term bias means We all know biasing, reverse biasing, forward biasing, but what is bias? A bias is a DC voltage is applied to control the operation of a device. When we apply DC voltage, direct current, direct voltage is applied to control the operation of a device. We will use it as to control the operation of device. In a LED, the light is produced by a solid state process called in LED. We know that in LED, electrical energy is converted into light energy. It is also known as light emitting diode. In various diodes, LED is also used. LED has the main significance in this. In this, light is produced by solid state. That process is called electroluminescence. In 13th question, efficiency of LED is given by the efficiency of LED has the efficiency that electrical power to visible light conversion. We also know that LED converts electrical energy into light energy, so it converts electrical power to visible light conversion. We will see light from the electrical energy it converts. In 14th question, the wavelength of the light emitted and its color depends on the light emitted, the how much light emitted, that wavelength, its color depends on band gap energy of the material forming PN junction. We know energy band is the band of various energies of semiconductor. So band gap energy of the material forming PN junction. Here will be the C option correct answer. Now in 15th question, the material used for red LED. In red LED, we know LED is made of two types, like green LED and red LED. In red LED, we use gallium phosphorus, gallium phosphate, gallium arsenic phosphate, and aluminium gallium arsenic, and these all. So here option D will be the correct answer. Now in 16th question, it is saying a silicon diode is in series with 1 kilo ohm resistor and 5 volt battery. If the anode is connected to the positive terminal, the cathode voltage with respect to the negative battery terminal is. We know in question it is saying that 1 kilo ohm resistor, it is connected in 5 volt of battery. If it is connected to the anode, if it is connected in cathode, there will be the always less than the 5 volt, but not more less than the not much less than the 5 volt. So if you will calculate this, the cathode voltage with respect to the negative terminal, then 4.3 volt will be the answer. Now in 17th question, although current is blocked in reverse bias, there is some current due to majority carrier. Although current is blocked in reverse bias, if current is blocked in reverse bias, then some small current flow due to minority carrier. This is called leakage current. It is also important question that what is leakage current. Then you should reply that leakage current is the current which occurs due to small current due to minority charge. When current is blocked, when it is reverse bias, then also a current flow due to minority charge carrier. So B option will be the correct answer. Now in 18th question, the average value of a half wave rectifier voltage with a peak value of 200 volt is. We know the average value of half wave rectifier is Vm by root 2 200 by 1.414. If you will calculate this, then 63.7 volt will be the correct answer. Now in 19th question, when a 60 Hz sinusoidal voltage is applied to the input of a half wave rectifier, the output frequency is. In a half wave rectifier, V input equals to V output, and frequency is also same. So here 60 Hz is input, so 60 Hz will be also output. So here C option will be the correct answer. The peak value of the input to a half wave rectifier is 10 volt. The approximate peak value of the output, the approximate peak value, it has to be said to find out. Then if you will calculate peak value of this output, then 9.3 volt will come. If you will solve this, then it will be the correct answer. Now moving towards the next question. The average value of full wave rectified voltage with the peak value of 75 volt. The average value of full wave rectified voltage with a peak value of 75 volt, then average value will be 53 volt. 53 volt, because if you will calculate this, V average equals to Vm by root 2, then 75 by root 2, then if you will calculate, then 53 volt will be the correct answer. When a 60 Hz sinusoidal voltage is applied to the input of a full wave rectifier, the output frequency is. In a full wave rectifier, V input frequency equals to 2 into V output. Then 2 into 60 Hz and 120 Hz will be the correct answer. Now in 23rd question, the total secondary voltage in a centri tapped full wave rectifier is 125 VRMS. Neglecting the diode drop, the RMS output voltage is. In total secondary voltage, we know that there are two types of full wave rectifier: center tapped full wave rectifier and bridge full wave rectifier. It is saying 125 VRMS. The RMS output voltage will be VRMS by 2. Then the answer will come our 62.5 volt. Now moving towards the next question. In 24 number question, when the peak output voltage is 100 volt, the PV for each diode in a center tapped full wave rectifier is. In center tapped full wave rectifier, it will be twice means 2 into V output voltage. Then answer will be 200 volt. The answer will come 200 volt. Now next question is saying the ideal DC output voltage of a capacitor input filter is equal to. Our input filter of ideal DC output voltage is equal to the peak value of the rectified voltage. Is equal to the peak value of rectified voltage. It is should be remembered. Now in 26th question, if the load resistance of a capacitor filtered full wave rectifier is reduced, the ripple voltage, we know ripple factor is when ripple factor will be high, then efficiency will be low, and vice versa. Then ripple, here question is asking that voltage resistance is reduced, is decreased, the ripple voltage will increases. Because efficiency, if ripple voltage if ripple voltage increases, then efficiency decreases. So these are inversely proportional. So a full wave rectifier is reduced, then ripple voltage will increase. Now in 27th question, if one of the diodes in a bridge full wave rectifier opens, the output is approximately in bridge full wave rectifier, we know there are four diodes. If one is opened, then the bridge full wave rectifier acts like a half wave rectified voltage, half wave rectifier. So there are always four diodes. If one diode will be open, then if it will act like half wave rectified voltage. Now in 28th question, the cathode of a Zener diode in a voltage regulator is normally the cathode, the negative terminal of Zener diode in a voltage regulator is normally more positive than the anode. It will more positive than anode. Now in 29th question, if a certain Zener diode has a Zener voltage of 3.6 volt, it operates in a when Zener voltage has has a certain Zener diode, then it will operate in Zener breakdown region. Then breakdown occurs in the Zener diode voltage. Now in 31st question, an LED is always operated in forward bias. Here we will check the option what is saying: emits light when reverse biased, senses light when reverse biased, emits light when forward biased, acts as a variable resistance. It will never act as a variable resistance. It will always emit light when it is in forward biased. Now in 32nd question, 32nd question, when operated in cutoff and saturation, the transistor act like when transistor is in cutoff region or saturation region, it will act like a switch. Now in 33rd question, in a voltage divider biased NPN transistor, if the upper voltage divider resistor VCC opens, the transistor goes into cutoff, it will break down. It will be in breakdown region. Now in 34th question, in a voltage divider biased NPN transistor, if the lower voltage divider resistor opens, if voltage divider resistor will be opened, then voltage divider biased NPN transistor, then transistor goes into cutoff or breakdown region. Now in 35th question, a certain common emitter amplifier has a voltage gain of 100 if the emitter bypass capacitor is removed. Then the voltage gain will decrease. Then voltage gain will decreases when common emitter CE amplifier, in CE amplifier voltage gain is 100. Voltage gain in common emitter there will be alpha in common emitter, no, there will be beta is equal to voltage gain, beta equals to voltage gain, it will be decreases. So here are 35th question completed. Hope you will like this video, you don't get bored. If you like this video, then please like, share and subscribe, and thank you for watching.